Okay, here's an exponential model word problem that got sent to me. We have a model here for the number of locusts, and T represents the number of days since the beginning of spring, right? And L of T is the number of locusts. So if we plug in a number of days since the beginning of the spring, then we can find the number of locusts that there are in an area, right? Okay, so we're asked to complete the following sentence about the rate of change of the locust population. Remember, the rate of change is always inside the parentheses here, okay? And the population of locusts gains 2/3 of its size every day. Now, why 2/3? Because 5/3 is in there. But remember, the rate of change is positive if it's over 1, okay? So this is 5/3 is really 1, right, plus 2/3, or 3/3 plus 2/3. So 2/3 is the amount of increase. That's the gain. If it was less than 1, it would be a decrease, right? The population would be decreasing as the time went move forward. Okay, so that's why it's 2/3. The other thing here is the population of locusts gains 2/3 of its size every how many days? And this tells you right here, the exponent tells you how often the growth factor gets applied. So, you know, if t is divided by 5.9 days, every 5.9 days, the growth factor of the population is going to gain 2/3 of its size every however many this denominator is, right? So yeah, after 1 day, it wouldn't have really gained the full 2/3 more locusts, right? It's every 5.9. This kind of divides however much time. And you can think about that if you start to plug in those numbers, you realize that if you plug in 5.9 for t, then the exponent's only 1. If you plug in, what's twice, 11.8, then the overall exponent's only going to be 2, right? So every 5.9 days, the population increases 2.3. Sorry, not 2.3, 2/3. So I hope that helps a little bit on this one.